Hey, good Friday afternoon, everybody. Brian Bledsoe with you once again, host of the Desert Farmer podcast. Great to be with you this afternoon. I know it's been a little while since we've chatted, but I've been very busy traveling across the western and central high plains, talking a lot about weather to a lot of folks. I was actually in Dalhart, Texas a couple of days ago. I'm going to be in Idalia, Colorado, coming up early this next week, talking to some folks about weather. And I spent an awful lot of time in west and southwest Kansas, so I am sporting my Ormiston Farms sweatshirt today that I shoveled about a foot of snow in today here in Castle Rock, Colorado. For those of you that aren't familiar with Ormiston Farms, they are a great bunch of folks right there in Kismet, Kansas. And I had the opportunity to go to a barn party that both Rock and Rocky put on. We got to hang out for a period of time. I got to see guys like Andy Mosier, Jason Becker, from those desert farmers. And it was just great to be able to sit down and chat with a lot of folks that I don't get a chance to sit down with on a regular basis. I know we do a lot of talking digitally, whether it's with text messages or phone calls or on Twitter, but it's always better to be able to sit down and chat. So big shout out to Rock and Rocky. Thanks so much for giving me some swag. And I obviously am sporting that for you guys today. All right, we got a lot to talk about on today's episode, from what the latest European seasonal model has to say, which just came out yesterday, to a couple of different takes on some analog years that I really want to spend some time on with you late this afternoon. Not that it's a perfect way to go about looking at long range forecasting, but in many cases, looking at past history gives us a good look at what could lie ahead for us in the future. And if nothing else, it helps to balance our risk. And I think that that's really what a lot of this is all about. Can we identify sources of risk coming up in the growing season that we're going to have to plan for, whether that is occasionally heat and drought, or if it's on the exact opposite side of the coin, if it's too cool, we've had too much water. And I know for a lot of us in the West and Southwest High Plains, that usually isn't the type of risk that we have to plan for once we go into the growing season. So I want to take some time with you today and kind of go through a lot of that stuff. Before we get down into some of the modeling, let's look at the short-term drought index, because I think that helps to tell a pretty significant story about who's in the worst shape and who's actually doing okay. And it's this corridor right here that's had a real problem. Southern South Dakota, most of Nebraska, southeast Wyoming, western Nebraska, northeast Colorado. You could even go back here over west central portions of Utah. But this area here has had a problem. Now, this corridor is getting water, all right? Talked a lot about that. That corridor is going to look quite a bit different over the next week or two than what it looks like right now. This corridor here is still not capitalizing on any type of moisture except for southeast Wyoming, southwest Nebraska, and northeast Colorado today, getting some decent snow. Like I said, here in Castle Rock, just south of Denver, I've got about a foot of heavy wet snow that's out there on the ground. So great about that. I wish it was just a lot more widespread. Farther south, this corridor for east central Colorado across parts of Kansas has done okay. But this area of northeast New Mexico, okay, and the panhandles and into western portions of Oklahoma have really struggled. Really, the past 90 days have been problematic. In fact, when I was in Dalhart this last a couple of days ago, there are places in and around Dalhart, Clayton, Tucumcari, Hereford, Dimmitt, Freona, Amarillo, northeastern up toward, Canadian, back to the north toward Boise City and Guyman that have really had between about 5 and 20% of average in terms of moisture. And there were several communities in the month of February in that area that did not see anything, not a drop of liquid, not a flake of snow that was significant. So the trick here is to get what's going on here to eventually come back. And early on in March, and even into April, that can be a trick sometimes, all right? That doesn't mean that we're completely dry. It just means that it takes some time to adjust the pattern to where we can actually make that happen. So I usually don't advertise the European extended model forecast here. This is a product that comes out every night that's based off the European model, and it takes a look at the next 46 days. All right. And I know you're thinking to yourself, man, what are we doing here? But, and this model has biases. So, and by bias, I mean, if it's dry in your location right now when it initializes, a lot of times it carries that flavor of the forecast throughout. Vice versa if it's wet too. So I'm going to break this down for you in a little bit different way. This is the 46-day precipitation anomaly that came out in the latest run. All right. So obviously it's got this corridor wetter than average because that's what's happening right now. This corridor, it has drier than average because it's dry right now and the pattern likely going to continue that way. And we're trying to make things wetter through this corridor up here to the north, which has actually been fairly dry. So what we're doing here is we're largely bypassing a good part of the west and southwest part of the country, and that bleeds eastward into the western high plains before we really start to kick things into high gear once you get farther east. Pattern looks familiar, does it not? I mean, we saw this materialize last year in the same way as we were transitioning out of a weak La Nina. The big difference, though, this year is that we are not just transitioning out of that weak La Nina, we are steaming toward a developing El Nino. And I'm going to talk a bit more about that here in just a second. But what I want to do with this next graphic is kind of slide things through the 30-day forecast period. All right. So it starts on, from March 5th through April 5th. That's what you get there. But notice as we extend out there deeper into April, do you see the dry signal adjust itself and start to rapidly shrink here across parts of the western high plains, even back here over California? And to me, what that might suggest is that we might start to get an invigoration of the subtropical jet stream for a chance and see some of these storm systems come in a little bit more of a southerly fashion that at least has a chance to hit some of these areas in the far west and the southwest high plains. Now, it takes time to adjust and get that accomplished. And I don't want to put a ton of stock in what this particular run of the model is suggesting. However, it is a change, and it is a favorable change to see that dry signal diminish as we get deeper into this forecast. So at the end of that animation, it would essentially take into account the pattern from March 20th through April 20th. And that's usually when we start to see some of these wetter adjustments take place over the west and southwest high plains. So just some food for thought to think about. Now, the temperature anomaly for that 46-day period is still a lot warmer, and it's warmer where you would expect it to be, where it's obviously has the chance to be drier through the southwest and up through the western high plains. In fact, some of the more high-end temperature anomalies are in this sector right here, from the Texas and Oklahoma Panhandle, east and northeast New Mexico on up here in the southwest Kansas. Now, does that mean that we won't see any more cold air? No, that's not what this means. It just means that for that month and a half period, that the flavor of the forecast is likely going to be warmer than average, where you see those warmer colors, and cooler than average, where you see the cooler colors. There is still a chance that we could get some late season cold plunges coming down from the north that may only last a day or two. But we are getting late enough in the season to where even if we do see one or two of these cold slices come through, it doesn't linger for a very long period of time. So that's what I wanted to share with you about that. Now, let's move on to what the current state of the oceans looks like. And this next graphic is going to be a 90-day animation. So it's the past 90 days looking at sea surface temperature anomalies globally. All right. So a couple of areas I want you to focus on right there. Okay. Remember, this started December 5th and it's going to end on March 5th. And you can see that cool area here where we maxed out that La Nina in late December. And it has just been rapidly diminishing and going away. Now, don't just watch the blue. All right. Watch this. Okay, off the west coast of South America. Watch that change for this run of the animation. And notice, once that blue goes away, it doesn't just sit there neutral. It goes rapidly warm. And in some cases, already 1.5 degrees Celsius above average, right there off the west coast of South America. Other locations to be focused on. The Indian Ocean, okay, has been warming up. we have a very positive Pacific meridional mode right here off the southwest coast of the United States, the Baja, out here toward Hawaii. We also have, okay, just general warm ocean here in the North and Northeast Pacific. And that's something that I think is very, very important. So as we go to what's going on right now, I'll talk a little bit about that. Historically speaking, all right, and I know that there can always be exceptions, but historically speaking, whenever it is warmer than average here in this quadrant, those waters right off the west coast of North America out toward Hawaii and off the Baja especially, okay, a lot of times we don't have to worry for moisture east of the Rockies, all right? That in conjunction with a rapidly vanishing La Nina signal, and we're steaming toward El Nino, is kind of reinforces that fact even more. We also have what inevitably is going to be a positive phase of the Indian Ocean dipole going on over here, okay? And I don't want to necessarily touch on the PDO phase here, but the PDO phase is the least negative that it's been since last year at this time. So I've talked a lot about that in previous Desert Farmer podcast episodes, that we are getting to the end of that PDO cycle where, this is year 28. A lot of times they last, between 20 and 30 years. So could this be a phase change coming that coincides with this developing El Nino, which would be an amazing thing? We'll just kind of have to wait and see. But that's what's going on with the oceans right now. And the thing to keep in mind here, too, is there's just a lot of warmer than average water that's been pooling up here in the West Pacific that is going to continue to slosh its way eastward once we continue to get some westerly wind bursts. And that's really going to steam us toward, the El Nino. Now, if we look at the trade wind forecast here, this is from the European Ensemble, okay? This is running from all the way back to February 4th, and this takes us all the way down to March 21st. So this black line is today, all right? And all of these blues, those are easterly trade wind enhancements, okay? Think of not fully going toward El Nino at that point, because these easterly trade winds were kind of holding back some of these westerly wind bursts. These red colors are westerly wind bursts. Now, today, we are coming to an end of some of that stronger trade wind activity out of the east. And look at what happens as we get deeper into March. These westerly wind bursts are going to start making their way farther east across the Pacific, taking that warmer than average water and sloshing it eastward. This essentially is going to continue to help propel us toward this El Nino development in a very rapid fashion, especially if these easterly trade winds go away altogether, like the latest European Ensemble is showing. And this only goes through March 21st, all right? So I know that that's the next couple of weeks, but that's a pretty significant change here with some westerly wind bursts getting on board and starting to have an impact. The latest Niño 3.4 index, all right, we're right there at about a negative 0.5. I'm expecting that to continue to do this. As I've been saying now for quite a while. Again, this was our max out right there in late December, and you can see the trend. So that's essentially where we're going, and I don't think we have anything that's going to hold us back right now, especially since those easterly trade winds have gone away. And then for those of you not familiar with this graphic, think of the upper left as Indonesia. Think of the upper right over here as South America. And this goes all, this is an animation, obviously, that takes into account what's been going on since late December. But what you need to know is look at all this warmer than average water here that's not only surfacing in the eastern part of the Pacific, right off the coast of South America, but is just ready to come to the surface here as soon as we can get some more westerly wind bursts. And that warm pool is all the way down to about 150, 170 meters deep. It's very impressive. And that right there is one of the main reasons why I think a lot of the modeling is just so gung-ho with this transition, not only in speed to El Nino, but in magnitude toward El Nino. In fact, the latest European seasonal model just came out yesterday, all right? And the thing that I want you to focus on right away is how closely packed together these lines are basically from now right through about June. This is the model exhibiting very high confidence in its forecast. Now, when it gets out here toward August and September, we've got some of these members up here as warm as 3 degrees Celsius above average, but even the least warm is down here toward 1.5 degrees above average, Celsius above average. So if you take just the mean, all right, just spitball in the mean here, we're above 2 degrees Celsius above average in that ENSO region, right there in the central equatorial Pacific. That puts us in strong El Nino territory, even if we just take the mean of this. If we take the lower end of this, it puts us in moderate El Nino. But I'm most focused on the speed that this takes place and the magnitude, because by the time we head into spring, we're up there at about 1 degree Celsius above average in that ENSO region. And that's a pretty significant change from where we are now. We would have to warm that area a full 1.5 degrees Celsius between now and May and June for that to take over. So very impressive. It's even more impressive than the one that I showed you in February. Okay, as we put that to a map, again, it's very easy to see what happens here. Okay, you can see all those red and orange colors rapidly replace the leftover blue there. But what you don't see here, okay, is any type of significant cooling in the sea surface temperatures off the west coast of North America and off the Baja. A little average to maybe cooler than average up here in the Aleutians, okay, but not anywhere else. All right, so that is continuing to be a very positive Pacific meridional mode right there. And the Indian Ocean dipole, okay, still very positive over here as we get deeper into this forecast. So a lot of things really reinforcing the fact we're headed toward El Nino. And the latest Bureau of Meteorology forecast out of Australia, by the time August gets here, takes us up here towards strong El Nino territory. But even May, remember, they have a little different metric. They take El Nino as positive 0.8 degrees Celsius, all right, versus the United States down here around positive 0.5. So certainly by May, it's got us in that El Nino territory and also exhibiting a very high confidence right there as far as this transition. So I've been on this El Nino train for months, and I know you know that, but I just want to be very transparent about the information that we're looking at that kind of reinforces that line of thinking, and not just in El Nino, but a lot of things are pointing to the fact that we may have a very strong El Nino by the time we head toward late summer and into fall. Okay, so the European seasonal model temperature anomaly forecast is going to have a lot of that built in. It is going to be, it knows where it's going with the El Nino situation. So if we look at this from March to September, its March forecast has a lot colder than average temperatures continuing up here across parts of Canada. Most of the U.S. warmer than average. Well, we've been that way now for the first 5-6 days of the month, but I still think there's going to be some cooler air come down through this corridor. A lot of the longer range forecast, from the European ensemble is supporting that right now. So while the whole month might be warmer than average, don't dismiss the fact that we're probably going to have some cool sneak in here from the northwest. Areas farther southwest, probably not going to see that cool. All right, this cool is going to be biased to the northeast, in the eastern northern plains, into the Midwest, and obviously into the Northeast, not down here in the Southwest. If we look at April's forecast, notice the only real significant, what I would call heat signal, is kind of pooled, in this corridor. And there's a little bit of that late season cool air signal that could still come down from the Northwest. Historically, that can still happen in April, although we might be getting a little bit late in the game, especially with how rapidly we're transitioning toward El Nino for that to be a play. But at any rate, the April temperature anomaly forecast just has, average numbers here across the Midwest, northern plains, and certainly warmer than average down here in the Four Corners and across the desert Southwest. If we go to May, the heat signal is out here to the west, all right? Not here to the east. There's a tick maybe above average here in the midsection of the country, but certainly nothing ugly in terms of the heat signal. Now, if this was out here, okay, then we might have a different discussion. But right now, that main heat signal is situated farther west. June, it weakens a little bit, but it is still mostly positioned out here to the northwest. Now, I will say this. If we don't have a whole lot of heat happening through here, what that indicates to me right away is that we are shoving water in the ground. All right. And I'll talk more about that in just a little bit. But the other thing of note is that if we're starting to warm things up here in east and southeast Texas and southeast Oklahoma, that might be an indication that the pattern is starting to dry out as we get deeper into June. Because when we go to July, you can see some of that heat building here across southern Oklahoma and east Texas. Some of that heat signal fades out here to the west, all right? And if we go to August, it really starts to show up here, okay, right there. And there's a lot of history that shows that as we progress with this transition toward El Nino, that the front-loaded water that existed in this corridor dries out later in the summer, and the moisture becomes more focused out here farther west, right? You'll see that in just a second. In September, a little bit of heat going on out here to the west, a little bit here, a little bit here, all right? But if we kind of shut off that rain through this sector, all right, then we will get warmer with that drying that takes place right here from southeast and east Kansas down through Oklahoma, central and east Texas, and down along the Gulf Coast. Let's look at the precipitation anomaly forecast. Same deal, March through September. March, for what I've shown you, I think this is spot on, all right? Obviously wetter through that corridor there, and I've shown you the reasons why. And maybe average to wetter than average up here, you know, for these northern areas too, all right? Southeast still stays drier than average. Now, watch what happens in April. That dry signal that existed here from the southwest out here to the western high plains, all right, reduces by a lot. We are still wetter than average through this sector in April, all right? But in time, I think some of that water, that moisture, is going to be positioning itself a little farther west. Certainly more west than what March has to offer for us. When we go to May, we are still wetter here. Texas, most of it still stays wetter. We reposition our drying signal up here to the north, all right, across parts of the Pacific Northwest, northern Rockies, into the northern plains. I don't buy this at all in May here in central Kansas. And I think the reduction of that dry signal means things are going to get more active through these areas here, even though you're not technically in the green. Remember, I know a lot of you look for where the green is, but also focus on where the brown is not. I think that's just as important, because when we go into June, you can see the signal there is pretty pronounced here in the western high plains and through the middle part of the country. Little dry signal here across parts of Idaho, west and northwest Montana. July, we start to dry things out, at least the way the model says it here. But if we shove a bunch of water in the ground here early, this may be overdone. We're wetter through this corridor here, a little late to the party with the monsoon here in the southwest. That's typical with a budding El Nino, okay? If we go to August, again, I'm not so sold, all right, on some of this. I think this sector probably has the best shot to be drier. But with the diminished monsoon here, I can't ignore that in some of these El Nino years, we do have the diminished monsoon. And then in September, it goes away, and we start to see the seasonal change take place. All right, and I know that's a long ways out there. So let's revisit some of these analog years. Now, what I've done here for March through September, I'm only focusing on the El Nino years that we transitioned rapidly and went toward a strong El Nino later. There are others that I've talked about, all right? And I'm going to show you what here. 1951, we started with La Nina. We made El Nino by June, July, August, and finished with a moderate El Nino, okay? Not bad. I just don't think we transitioned fast enough through here. So we're not putting that one on there. 1957 is still with me. Weak La Nina signal, okay? El Nino by March, April, May. And look how fast we transitioned here. From Feb, March, and April, we were at a negative 0.3. We went to a 0.6 there. That is a rapid transition. We went to strong El Nino by November, December, in January of that time. 1963. Did we transition to El Nino? Yes, but not until June, July, August. And we kind of messed around neutral here in the spring. So while that is a transition year, not one of my favorites. 1965, again, I don't think we transitioned quickly enough. All right, not bad because we transitioned more quickly than 63. And 65 was a very wet year in the Western High Plains with that transition toward El Nino, but it's not right at the top of my list. 1972 is. We transitioned from that La Nina, El Nino by April, May, June, went on to strong El Nino status by later that year. What about 1976? Nope. We hung on to the La Nina signal too long, even though we went to El Nino late. What about 1997? I like 1997 a lot. La Nina signal there, budding El Nino by April, May, June, one of the strongest El Ninos on record to finish that year. 2000s. What about 02? I'm not on board with 02. First of all, I think it took us, we didn't have a La Nina signal early, and then it took us a little bit longer to transition, all right? What about 09? Again, we held on to that La Nina signal too long, transitioned to El Nino by July, August, September, too late. 2 teens and 20s. What about 14? I've heard a lot of people kick 14 around. Well, you know what? We didn't go to El Nino that year, all right? What about 2015? 2015 is interesting because while we didn't have La Nina early, we went to strong El Nino late. And so for a good part of the summer, we were totally in El Nino conditions right there. And while 2015 may not be the perfect analog about how we're transitioning, I think 2015 does deserve some attention. And I'm going to break it out in a little bit more detail here in a little bit. So hang with me on that. 2018, again, we hung on to the La Nina signal too long and went to El Nino too late. So I don't think that's a valid analog. 2023, I think, is, because we were El Nino right there, went to a rapid transition to El Nino, and we had a strong El Nino as we finished. I think we are transitioning more quickly than what we even did in 2023, all right? But it's kind of in the same ballpark right there. So let's see what these analogs look like. And I know I've gone over some of them with you before, but this is just the ones we're looking at today. 57, 72, 97, and 23. Temperature anomalies for March had some cool air coming down. Does this mean it's going to be colder than average like these averaged out to be? Probably not, but there's still a signal of some cooler than average air coming down. Precipitation anomaly-wise, we were drier back through here, wetter through here. Kind of looks similar, right? Especially the farther west and southwest you go, all right? I would say that with March, that really this corridor here is probably the driest part that we're going to have to deal with, all right? What about April? April. We had some late season cool air come down here, okay? Just like that. Again, doesn't mean that the whole month is going to be colder than average, but that late season cool signal was there. What about precipitation anomalies? Well, Texas, Oklahoma, east, northeast New Mexico, and southeast Colorado got wet. We had some lingering dry signal showing up across parts of this region, especially over Iowa, Wisconsin, all right? Most of Kansas was average precipitation-wise, but bottom line, we were making things stormy through that sector right there with moisture coming in from the Gulf. In some cases, a lot wetter than average from central and east Texas, eastward into Arkansas. What about May? May, we were a lot warmer than average up here, and we were cooler than average farther south. Look at West Texas, up into the western high plains here. That's because it was raining. We had more cloud cover. You know the drill. If we're putting water in the ground, it's likely going to be cooler than average, and that's exactly what we did. The precipitation anomalies went from very wet over south and southeast Texas and West Texas on up into the western high plains. There was still that dry signal here in all of those years across parts of the Corn Belt. And notice that we were already drying out through this area here across East Texas, eastern Oklahoma, Arkansas, Louisiana. And we were focusing the moisture farther west. All right. Northern Rockies, again, still not a crisis. What about June? June was cooler than average southwest and southeast, warmer than average over the top. precipitation anomaly wise, we were pretty dry in those years across most of the Corn Belt, especially the Western Corn Belt. But we were wet in the Western High Plains. We were starting to see, again, more dryness take shape here in parts of Texas. Wetter farther west and northwest too. July, temperature-wise, we started to cool things off northwest, and here's where our heat signal really started to come into fray here, okay? Arizona, southern New Mexico, the south half of Texas, all right? And that's because we dried it out. Notice, this is July. We should be monsooning here in the southwest, but a lot of times in El Nino, we're late to the party with the monsoon, all right? And notice the dry signal here across central and east Texas. So with all that moisture early, we slammed the door on that by the time we got to July. And at some point, we would have to start worrying about flash drought here across central and southeast Texas. It's been in the history books for a long time here. We start to fracture some of that dry signal in the Western Corn Belt, but it's still there for others. We don't entirely get that accomplished until August. Now, August, we still have some lingering heat here. We were cool out west. We were cool east, basically average in the middle. And then we weakened that dry signal a lot here across parts of the Corn Belt. But we still had it very prevalent through this sector. Central and East Texas, southern Oklahoma, the Gulf Coast, and up the Mid-Atlantic. Monsoon showed up here. We still did okay through the Western High Plains as we continued to recycle the moisture and tap some of that monsoonal moisture that came in August. All right. And September. Late season heat, you bet, especially across Texas. Out west, we were cooler than average. And from a precipitation anomaly standpoint, we still had some lingering dryness here across parts of Texas. No drought signal one way or another here in the Western High Plains and Northern Rockies. Some scattered dryness, I suppose, through the Eastern Northern Plains and on in the Corn Belt, but nothing terrible, all right? Okay, so with that in mind, let's look at 2015, because I told you we were going to look at that one. So for 2015, let's look at the temperature and precipitation anomalies from March through May. Remember, in that period of time, we were already technically meeting El Nino criteria. So we were, kind of rapidly moving ahead of where we are right now, all right? But even so, I still think we may even be a little bit ahead of that, all right? So in March to May, temperature anomalies, we were warmer over the top, cooler south and southwest, warmer southeast. And from a precipitation anomaly standpoint, does that look familiar? All right, I think so. Okay, we were wetter than average in these places here. Drier than average farther northwest, a couple of little dry signals here across parts of the Corn Belt. But if I wanted to shrink that down even a little bit more, all right, if I wanted to go month by month, I think that would show up a little bit more clearly. But clearly, we get wet here across the central and southern plains and into the western plains, especially by May. And then if we look at May to July, these were your temperature anomalies. We were hot here, northern Rockies and northwest, cooler pretty much in that sector, and then we were hot east and southeast. Precipitation-wise, we were still wet through a good part of that, all the way through 15. And I think it's because we had that El Nino signal present during that time. Some of these wet anomalies were very significant, even record wet in some cases. And when we go to July to September, this was the temperature anomalies, July to September. This is where the heat really started to show up, right through the middle part of the country, all right? And that includes the western and southern plains here, all the way down the Gulf Coast. There were really no areas here that were immune to the warmth that we saw in the July to September of 2015. And precipitation anomaly-wise, look what happened here, okay? We really dried things out here in central, southeast, and east Texas along the Gulf Coast. We were still wetter than average here. Again, we did average precipitation through there, but if you were in one of those spots that were drier than average in conjunction with the heat, all right, even up here across southern parts of North Dakota, then you were in a problem spot right there. The goal of what I just went through, folks, was not to really, say this is exactly what it's going to be. My goal is to present to you some information that is going to be, used in a practical fashion. as we go forward. And these analog years are going to continue to change as we get closer and as we see this, we move toward this El Nino event. Are the models too overzealous with what's going on? Probably not, given the signals that we are seeing right now. So it just kind of depends on the timing and how we skate through the spring and early summer to try to hone these analog years down to see what exactly is going to happen. Right now, it's pretty much on brand with this transition where the west and southwest high plains are drier than average. And once you get farther east, things are wetter. So right now, we're kind of continuing to skate through with kind of how it should be. And then we're going to kind of have to see how we pivot by late April and into May if we can yank that moisture far enough back to the west to really set things off in the western plains. Because if you go through all these analog years, it's really May that is the trigger point for the west and southwest high plains that really gets things going. And history is a great teacher. So if we can kind of pair that history with some of the model data that's going on, I think that's at least the best we can do with the forensic evidence that we have before us, folks. So I hope you enjoyed this episode of the Desert Farmer Podcast. I hope you're well. I'm going to be chatting with you again here real soon as we get more information in. But I just greatly appreciate your listenership. Thanks for hanging with me, and we'll be chatting with you again here real soon. Take care.